Good evening to all of you. Today we are going to do solution of transcendental equations, and we do transcendental equations using numerical methods. All right. A very good evening, Bocha and Amar Pandit. I welcome you to this session. My name is Rahul Kanyal. I've had a master's degree from Indian Institute of Science, Bangalore in design. And I also have an experience of around 2 years in a PSU called BYJU'S. All right. So please tune to us so that we can start. So let's get started by understanding what exactly is transcendental equation. Even before that, we have cool discounts coming up, guys. Okay. So this is a code that you can use to get around 30% of discount in our courses. All right. So and these are some of the lucky winners. All right. And let's get started quickly. So what is a transcendental equation? Transcendental equation means that anything that has, ln x e to the power x or trigonometric functions like sin x. Is that it? For example, let's say we have to solve cos 10x equals to 10, right? This one is a transcendental equation that we cannot use this, we cannot use anything else to solve such kind of equations, right? So that's why we use numerical methods. Obviously, you can use something like, x squared plus 2x plus 3 equals to 0. We all know how do we solve these simple equation, algebraic equation, all right? What if you have something like that, cos 10x equals to 10, all right? So for using or for solving these type of equations, we have numerical methods. Is that it? Yes. So I hope that transcendental equation is clear to you. Okay. Now how do we solve them? Okay. How do we solve them? So the first method here is nothing but bisection method. Okay, now this is what we need to solve. So we just say that, okay, let's say fx equals to x plus ln x minus 2. We are going to solve this. So we have just assumed a function like this because it's already given to us. Okay, yeah. So yes, and between 1 and 2, okay, and let's check what comes in 1 and 2. Okay, so I'm going to just check the value of f1, so that we get as 1 plus ln 1 minus 2, that is nothing but minus 1. Yes, f2 is nothing but 2 plus ln 2 minus 2, that is around 0.69. Okay, so what it says is okay, so let's say this is 1 and let's say this is 2. Okay, I'm going to just take it off. Yeah, so what it says is at 1 the function is negative, right? Minus 1. So we have a negative value here. For 1, x equal to 1, the value of function is minus 1, all right? And for 2, the value of function is positive, that is 0.69. Okay, so it's over here. So what we can conclude is that this function, okay, will have at least one root between 1 and 2. Right, this is what we can say, isn't it? It might look like something like this. It might look like this. It might look like this. Right? Isn't it? Huh? And so many things, but we don't know how does it look like, but we just know that there's one root in between 1 and 2. Yes, that's true, right? Is that it? Hello. So you need to understand this, okay? Okay, and the condition for having a root, I'm going to repeat, the condition of having a root in an interval is just given by, here what is happening? f1 into f2 equals to negative, right? Because f2 is positive, f1 is negative. So if you multiply it, it's going to be positive. It's always coming out to be negative, right? So whenever this thing happens, we say that there's one root in this interval, 1 and 2. All right. Yes, so we conclude that there's a root in this interval. Means we are talking about, okay, let me not write it there. Okay, so what we say that there is one root in 1, 2. Okay. All right. Yes. Now, how do we solve that? Okay. So we say that there's a root between, there's a root in this interval. So the first approximation that we make is nothing but 1 plus 2 upon 2. We take the average of this. Okay. We take the average of 1 and 2 because it's already given. All right. Abhinash, yes. What is transcendental? Transcendental means a function that can have e to the power x or ln x, or let's say trigonometric function like sin x, cos x, tan x, and so on. Okay, that is what we mean by transcendental equations, and we use numerical methods to solve such kind of equations. Okay. Transcendental. No hurry, we don't have shortcuts for this. Okay, we have to follow algorithms here, and these are tried and tested algorithms. You cannot challenge them. Okay, so x1 equals to, we say that it has to be the average of 1 and 2 because it's already given to us 1 and 2, because we have already, it's given to us, right? We have to find one root between 1 and 2. That's why we just take the average of them, and what do we have? We have x1 equals to 1.5. All right. Yes, now there seems to be, yeah, good. So it came back. All right. Now what? Now we just need to find f of x1 equals to f of 1.5. That is nothing but, because fx is this one, I'm going to substitute the value of x in this. So what do I get? 1.5 plus ln 1.5 minus 2. Okay, now I have written down these in my notebook because I don't want to calculate them and waste my time. All right. Yeah, chalo. So what is that? So 1.5 plus 1.5 minus 2 is nothing but. All right. Yeah, Shubham, it's fine if you're late. It's fine. Okay. Don't worry about that. Okay. So yeah, what is approximate solution? What is bisection method? I'm already talking about it, Ankita, all right? We are talking about bisection method that says that, okay, first assumption that I'm going to make here is, let's take x1 equals to 1 plus 2 upon 2. All right, why we are taking that? It will become clearer to you, okay? That's all. Chalo. Now f of x1, we said that, okay, we have started in this interval 1 and 2. Okay, so we say that, okay, let's take the average of these two, and that is nothing but 1.5. Okay. Yeah, Abhinash, this can also be solved by Newton-Raphson. All right, and we are going to do that. Okay, and Newton-Raphson, just hold on, we'll do it in the last. Okay, chalo. So f of x1 is nothing but the value of function at 1.5 is coming out to be negative, like this. Okay, it's somewhere over here. It's a negative, so I'm going to use another marker over here. So it's negative. So what can we say? Can you please type in? What can we say? Root lies in between what and what? Just type in your answers, guys. Just type in your answers. Root lies in between what and what? It lies in between what and what? Did you get the answer? Or did you get the question first? So obviously, see, now the value of function is negative here, it's positive here. So we can say that, the root lies in between. Calculated it. X f of 1.5, that's negative, right? Okay, yeah, it's coming out to be minus 0.094. I'm again going to check it so that we don't make mistakes. All right, so yes, So we say that it's in between 1.5 and 2. That's why second iteration or second step can be what? 1.5 plus 2 upon 2. That is nothing but 3.5 upon 2. That is nothing but 1.75. Because it's negative here and it's positive here, right? The function's value is negative here and the function's value positive here. So it will go something like this. It will go something like this, right? Let's say. So it will have a root in this interval. That's what we have been trying to tell you. Is it good? I think this is good. All right. Yeah. So x2 is nothing but 1.75. So we just say that, okay, it's 1.75 here, this point. Now, again, we are going to find f of x2 equals to f of 1.75 equals to 1.75 x plus ln x ln of 1.75 minus 2. Okay. Yeah, so if the value of function comes out to be 0 at that point of time, so that becomes a root, all right? That is nothing but the root, Amar Pandit. Yes? Is that it? That has to be the root of that function, and our job is done if value of function comes out to be 0. Yes? Okay, fine. So what is this? Again, 1.75 ln minus 2, right? So I'm going to just see what is the value of this. So 1.75 plus ln 1 minus 2 is 0.309. So at 1.75, it's going to be 0.309. So it is positive over here. Okay. So again, I'm going to make this. Okay, so at 1.75, it's positive, like this. So what can you say? Root lies in between what and what? Just tell me, root now please tell me. This is important, all right? Root lies in between what and what? Yes, Amar Pandit. Then you will stop there, all right? Yes, you're right. You are going to stop there because you have already found the root, the exact root. Is that it? Yes? Yes. So Shubham say that it lies in between 1.5 and 1.75 because here it's negative. The value of function is negative and here the value of function is positive. So it lies in between 1.5 and 1.75. So what should be the value of x3? What should be the value of x3? Yeah, good. Now you're getting this. Yeah, Abhinash, Amar and Abhishek, you're right. 1.5 to 1.75. It should be somewhere over here, right? In this, because this is negative and that is positive, right? Yeah, good. Well done. So what should be x3 now? Can you please typing? Okay. Bocha, I already told you that, for example, this equation, how can you solve this equation? Can you solve this equation? Can you solve this equation? No, right? So you have certain methods to solve these kind of equations. So we are trying to get those. Okay. So what can be the value of x3? That is nothing but 1.5 plus 1.75 upon 2. Right? Equals to? Please tell me the value of, yeah, exactly. So average of 1.75 and 1.5. Okay. Yes, so 1.625. Is it good? Yes, Abhishek, just keep on working in this. It will become interesting, all right? So x3 is nothing but how much? 1.625. Okay. Is it good? Yeah, good, good, good. So x3 is 1.625. Now please find this value. F of x3 is how much? F of x3 is x 1.625. Also now, okay, now one more information for you guys, okay, because it's mentioned over here, correct to one decimal place, okay, correct to one decimal place. So we are going to just use two decimals, and it will become clear to you why we are doing so. Okay, it will become clearer to you. All right, okay, fine. Now x3 equals to 1.5 plus 1.75 upon 2 equals to 1.62. Okay, is that good? Yes, yes, yes. Everywhere you have to use just two decimal places, and we'll see why we are doing that. Okay, so f of x3 is nothing but 1.62 plus ln of 1.62 minus 2. That is nothing but, I'm going to look at my notebook, 1.62 plus ln 1.62 minus 2 equal to 0.10. So 0.10. So again at 1.62, that is over here, 1.62, okay, we are getting a positive value, so it's over here. Now root lies in between what and what? I hope you're understanding it, right? At 1.62 is positive, at 1.5 it's negative, so where does the root lie? Yeah, good, Shubham. Lies in between 1.62 and 1.75. No, 1.75 is already positive, right? So Ankita says 1.75 and 2. How come 1.75 and 2? Because they are positive. How can a root be in between 1.75 and 2, right? So Amar, so what's your call? 1.5 and 1.62. Yes, because at 1.5 it's negative, 1.62 is positive. We just calculated it. Yes, we have been talking about that. So you are right, Abhishek and Shubham and Amar as well, 1.5, and Abhinash as well. Okay, so it lies in between 1.5 and 1.62. So what should be the next approximation? Right, so the next approximation has to be, I'm going to delete this. Can you please write in your responses in there? What should be the next approximation? What should be the next approximation? Yeah, so we say that x4 equals to 1.5 plus 1.62 upon 2. Yes, so how much are you getting that? Is it 1.56? Right, the average of this and this, that is nothing but 2 to 1, 3.12 upon 2, right? $1.56. So okay, let me just this. So 1.56. If you are saying so, it's going to be 1.56. Okay, yeah, so good, 1.56 if you're saying that. Okay, x4 equals to 1.56. okay, now what is the value of this? F of 1.56, that is nothing but 1.56 plus ln of 1.56 minus 2, that is what? What is this? So point, okay, fine. So I'm going to just write it quickly, otherwise we are not going to finish it. 1.9 is nothing but it's positive, right? It's coming out to be positive 0.004. Yes, so 0.004. I have just mentioned they're positive, all right? So 1.56 over here, let's say this is 1.56. Let's say this is 1.56. It's also coming out to be positive. Okay, 1.56, this is the value. This has become a bit messy out here. Okay, yes, now, yes, good to see that. Now what should be the next step? x5 equals to how much? Root lies in between what and what? Now please tell me, root lies in between what and what? Yes, it lies in between 1.5 and 1.56, because 1.5 is negative and 1.56 it's positive. Yes, good, Amar, right? So x5, we say that 1.5 plus 1.56 upon 2, that is what? 1.56 plus 1.5 upon 2. So what is the answer? Yeah, exactly, good. Ankita, yes, you're doing good. So yes, 1.53, good. So 1.53. Okay, now we stop, all right? Now we stop here, because there has to be a limit when we stop. Then why do we stop? Because it's mentioned that correct to 1 decimal place here, right? And here what we have, 1.56, and the next one, x4 was 1.56, the next one, x5 is 1.53. So this 5 is getting repeated here and here, right? Is that it? So we stop here, then we say that, okay, fine, so I'm going to just erase this quickly. Okay, then we say that, okay, this means x equals to 1.5. 1.5 doesn't look like 5, so I'm going to say x equals to 1.5. all right, did you understand that? Because it's mentioned 1 decimal place accuracy, that's what we are talking about here. So here it's 1.56, here 1.53, and this 5 is getting repeated, right? 1.5 here and 1.5 is getting repeated. So yes, we say that x equals to 1.5 is the answer here. All right, guys, is it good? Yes, hello, hello. How to find number of iteration required to achieve accuracy? Yeah, see, for example, here is just given that, you know, 1 decimal place. How many iterations did it take for this? How many iterations did it give? In this, how many iterations did it give? 4? Was it 4? Iterations means step, right? x1, x2, x3, x4, x5. How many? Were there 4? Because I'm watching 5 here, right? This one was the last one, the 5th one. And we have started with x1, so there has to be 5 iterations out here, right? Yeah. Okay. So for 1 decimal place, yes, there are 5. Okay. And for 2 decimal places, there might be many out there. Okay. So that's how it is done, and yeah, so that's all. Is that good? Okay, fine. So let's continue with the next one. Now the same thing is there. Fx equals to x plus ln x minus 2. We say that, okay, let's use Regula Falsi method. So Regula Falsi method says that, okay, the first iteration, or iteration means step, all right? Okay. See, Abhinash, okay, fine. Abhinash, if you're saying that, okay, is there a formula for this? Actually, see, if it's just given that 1 decimal place, all right, then I don't think there's a formula, okay? If there's an accuracy given, then there might be a formula, okay? So that is nothing but b minus a upon 2 to the power n is less than equal to error. Okay, if error and accuracy, you know, they are already given to us, okay? Error and accuracy are same over here. unfortunately, yes, error doesn't look like, you know, the same as accuracy, all right? But still, yes, this holds, all right? So there's also a mod in here, modulus, and n equals to number of iterations. If you have n equals to number of iterations. Okay, is that good? B and A here, B equals to 2, the higher limit, and A equals to 1, this one. That's what it means. Abhinash, okay. N equals to number of iteration less than or equal to error if error is already given to you, all right? That's how it is. Is that good? On simplification, what will be N? See, if error or accuracy is already given to you, then yes, you can plug in the error or accuracy over here, all right? Okay, here it's not given to us, unfortunately. All right, because some error or accuracy is desirable to us. We always talk in terms of errors and accuracy. All right, if that's given, you can use this formula and be done with a number of iterations. All right, that's what it means. Okay, chalo. Now, let's do this. Correct to one decimal place, it lies in between 1 and 2 using regular Falsi method. All right, yes. Okay, good. As you mentioned, so what does that mean, Amar? Assume and simplified. Can you please elaborate your answer? Okay, so what it says is x2 equals to x0 minus x1 minus x0 upon f of x1 minus f of x0 into f of x0. All right, now x0 here is nothing but 1 and x1 here is nothing but 2. F of x0 is still, we had to calculate it, right? So that's what, minus 1. 1 minus 2 equals to minus 1. And f of x1 is nothing but 0.69. So we say that, that's what, you know, so we say that root lies in between 1 and 2, that's all. Okay? That's what it is. Yashwant. No, Yashwant, I didn't visit IISc Bangalore, okay, because today I'm in Noida, right? Yes, it has to be opening day, okay. Is it opening day? What's date today? 29th. Okay, fine. Saturdays, yeah. They have opening day on Saturdays or on Sundays, right? Yeah, Abhinash, okay. If the formula is huge, yes, so let's see that, all right? There's so many formulas in there. We're just trying to grab some concepts here, guys, okay? The formulas are not very much important, but still, you know, some concepts. All right, chalo fir, now x0 is 1. Can you please try to find this, okay? So x0 is 1 minus x1 minus x0 is 2 minus 1 upon f of 2. F of x1 is nothing but 0.69 minus f of x0 is minus 1, so it becomes plus 1, okay, into minus 1. All right, so how much are you getting? So I think I would have calculated this. 1 minus 1 into minus 1 upon this is coming out to be 0.40. All right. Yeah. No, Abhinash, there cannot be any shortcut methods for this, okay? It's based on iterations. It's based on you know, a progressive approach towards the root. Okay, if it has to be solved like this, it has to be solved like that. That's what numerical methods is. Okay, if someone has given an algorithm, if Newton said that, okay, that's what, you know, the formula for or a model for subsequent iterations are, then we have to accept that. Okay, numerical methods, we cannot be flexible here. We have to follow formulas, models and all. Okay, that's what it is. F into x0 is -1, so that's what it is, 0.40. All right, Abhinash, I was replying to you. Okay, fine. So can you please tell me what is f of x2? That is f of 0.4, right? We have already calculated it, right? F of 0.4, f of 0.4 is -2.51, -2.51. So what can we say? Root lies in between what and what? Again, we are going to take that, okay? Reach the root in case of GATE. Yeah, Abhinash, but you know, let me tell you that GATE never asks entire question. I will let you know, just be with me till the end of this video. All right, I'm going to tell you that what kind of questions do usually come, okay, because it takes lots of time. Yes, but we need to know how to approach this. All right, so don't worry for that. Okay, this entire question is never going to come. Maybe it comes, but you know, generally it doesn't come. They just say that, okay, just tell me after 2 iterations what should be the value of x, what should be the root of x after 2 iterations, after 3 iterations maximum, that's all. So don't worry about that, okay? Yeah, so f of x2 is this one, so I'm going to again write this. This is 1, okay, this is 1, this is 2. All right, so the first guess is nothing but 0.4. So we are getting a 0.4 here. Let's say 0.4 is here, and in 1, x1, this is negative, right? The value of function is negative here, so I'm going to just mark a negative here. All right, so f of x1 is positive over here. All right, now f of 0.4 is nothing but -0.251, so that's what, a negative. So we say that root lies in between. Yes, Abhishek is correct, 0.4 and 2, right? Yeah, Ashutosh, a very good evening. Ashutosh, how can you converse faster? You don't have to use Regula Falsi, okay? If you want to converse faster, then use Newton-Raphson. Newton-Raphson is faster, right? Yes, so 0.4 and 2, you say, right? 0.4 and 2 is where, you know, the root is lying. Yes? Okay, so I'm going to just delete this. All right, so remember that what we did 1 iteration. All right, now what do? You just put x0 equals to 0.4 and x1 equals to 2. In this equation you just need to put, so what do you get? You get another x2 equals to, can you please plug in these values? So what are you getting? All right, Mani Yadav, a very good evening. Ashutosh Mishra, another a very good evening. Oh, I got messed up there. Yeah, good evening. Okay. Okay. Oh yes, this is the mistake that I made. Sometimes, yes, it happens. Sorry for that. So it has to be 0.4 here, 1 is here, and 2 is here. Yes. So what are we getting? 0.4 and 2. Okay, so f of 1 we are getting a negative, f of 0.4, how much were we getting f of 0.4? F of 0.4 we were getting negative here, right? And yes, so we say that is between 0.4 and 0.2, x1 equals to 2. So how much are you getting for that? Okay, just tell me. Okay, yeah, chalo. Yeah, so Amar Pandit, convergence is nothing but, the speed. All right. And the more the convergence rate, the better the speed is. Generally speaking, Newton-Raphson is the fastest of all. Amar Pandit, okay? So if you want to increase the convergence, then obviously you need to use Newton-Raphson. That's what I can tell you. All right? Yeah, chalo. Let's do this again. And can you please tell me what are you getting in x2? Again, okay, x2 I have written here. Again, I have written x2. So, because it's just about, coding. Whenever we are going to code this, then obviously we can replace these variables out there, right? Yes. Chalo, so Mani Yadav, this is the formula for regular Falsi method, all right? And x1 is 1 because this is given to us 1 and 2. And these values I've found out using this fx is nothing but this. So once you plug in, sorry for that, excuse me. Okay, once you plug in these values in this, you're going to get this. And you just need to put in these values, that's all. That's what it is. All right, Mani Yadav and Nitin Dada. So how much are you getting this? x2. x1 equal to 0.4, x1 equals to 2. All right, so, okay, let me write it. So you are getting 0.4 and 2, so you are getting 1.65. Are you getting 1.65? Are you getting 1.65, guys? Okay, so you'll be getting 1.65. Don't worry about that, okay? That's okay, fine. Okay. Sai Kumar Reddy, actually you need to practice, all right? Because if you are a diploma student, then you need to go back and go back to 11th, 12th, right? And then from there you can pick it up. Otherwise, it really becomes difficult, all right? Is it good? Yeah, so you will be getting a 1.67 or 1.65. Abhishek is getting 1.67. According to me, I was getting 1.65. So it doesn't matter, okay? It's fine. Okay, so let's say that we are getting 1.65, okay? Now, what is f of x2? F of x2 is 1.65 plus ln 1.65 minus 2. Is it positive or negative? Let me check that. Okay, it's 0.150. That's 1.150. So 1.65 should be over here. 1.65 should be here, right? 1.65 should be here, and function is positive over here, right? At 2 also it's positive, right? So what can we say about the root? The root lies in between. Come on, guys. Root lies in between what and what? Root lies in between, obviously, what? Could you get that? Root lies in between 1 and 1.65 because at 1 it's negative and at 1.65 it's positive. Yes? Is that it? Yes? Okay. But you won't take 1, right? Would you take 1 or 1.4? That's the question. 1 to 1.65 people are saying, okay? Okay, fine. So 0.4 and saying that 0.4 and 1.65. Actually, it should be in between 0.4 and 1.65 because we have already started with 1, right? Okay. It should be actually 0.4 to 1.65. All right. Because we already started with 1. Next was 0.4. Okay, then we said that, okay, it's in between 0.4 and 2. Similarly, we should say that it should be in between 0.4 and 1.65, okay? it should be in between 0.4 and 1.65. So you can go again you can find, you know, again you can put x0 equals to 0.4, okay, and x1, okay, put x0 equals to 0.4 and x1 equals to 1.65. Is it good? Okay, and apply this formula. Apply this formula again and again and again, and I think in 5th iteration you are going to get the answer of 1.5. Is that good? But don't worry, my job is to tell you the whole solution, all right? And in GATE or ESE, I don't think that they're going to ask the entire thing. Maybe in the mains paper, maybe they ask that, but still. Okay, you're getting that? Hello? Still, let me tell you that when you go ahead like that, whatever we did in bisection method over here, you know, you will be getting the value of x as 1.5. Hello, is it clear to you? Is it clear to you? Yeah, Nitin, yeah, good. Okay. Yes, now comes, okay, the same question we are going to use. We are not going to use regular Falsi. Okay, so we are going to use another method called Secant Method. All right, Secant Method. So what it says is, okay, what it says is, okay, the formula remains the same, all right? In Secant Method, it is just a sister of regular Falsi, all right? Yes, so what is that, Abhishek? Can you please tell me? 6.19 you have written, all right? Abhishek. About Secant Method, okay, fine. So the formula remains the same, all right? So x0 is nothing but 1, x1 is 2. Again, here, this is 1, this is 2, all right? The value of x2, okay, Abhishek, okay, then the similar procedure can be found out in regular Falsi whenever there's a repetition of 1.5, let's say 4th iteration it is giving you 1.56, and 5th it is giving you 1.57, so 1.57 becomes the answer for you. Okay, 6 is okay, fine. Is that good? So we are going to use this again, Secant Method, and yeah. So if you plug in this again, you're going to get a 0.4, right? Because everything is same. All right, everything is same. Yes. Hello. Yeah, exactly. So 0.4 we'll be getting. Now what do we say? We say that x3 equals to, now, okay, even before that, we just need to find f of x2 is f of 0.4. So how much were we getting? F of 0.4. So I'm going to write f of 0.4. Yeah, minus 2.51. Minus 2.51. All right. Now in this method there's a slight change, all right? Yeah, good Amar, Shubham, all right, good. So there's a slight change. We are not going to check again and again if you are getting a positive value or a negative value, all right? So this method is actually faster than the previous method. Okay, so I'm going to write here x3 equals to, here see, if you talk about this subscript, all right, x2 equal to x0, there's a difference of 2 here, right? 2 minus 0. Okay, so I'm going to write x3 equals to x1 minus, I'm just going to generalize this to this. Are you getting this? So x3 equal to x1 minus, now what should be this? There's a difference of 1 in the subscript, right? 2 minus 1 is 1, right? So here it should be x2 minus x1 upon f of x2 minus f of x1 into f of x1. Is it clear to you? Is it clear to you? I or an I? Yes or a no? Come on. Is it clear to you? Yeah, Mani Yadav says, yeah, good. So, you know, x1, what is the value of x1? x1 is 2. Okay. And x2, we just calculated 0.4. You just need to plug in these values and you are going to get x3 equals 2. So x1 is that thing. So yeah, so what are you going to get? X1 is nothing but 2, right? Yes, so you're going to get 1.65 here. All right, 1.65. Is it good, guys? Again and again we need to repeat the same thing. This is very easy stuff, and let me tell you that if you're not getting this, go back home and repeat this, all right? Otherwise it is going to be difficult. Okay, yes, so how much are you getting? 1.65, right? So again I'm going to write x4 equals to, what should be x4? So I'm going to just generalize this thing, okay? And we are not finding if we are getting a positive in this or a negative in that. We used to do it in the previous method, Regula Falsi method, all right? Yes, hello. So x4 is going to be nothing but x2 minus x3 minus x2 upon f of x3 minus f of x2 into f of x2. Is it good? Yes? Yes. So what are you going to get over here? And you can calculate that, all right? And whatever we discussed in bisection method, you are going to stop if there's a repetition of number in the first decimal place. Okay, similar to whatever we did in bisection method, right? Is that good? Hello? Is it good? This is just simple stuff, guys, all right? But let me tell you, let me ask you a question. Do you think this method is faster or Regula Falsi is faster? Is secant faster than Regula Falsi? I or an I? What do you think? Is secant faster or Regula Falsi is faster? Huh? Amar Pandit says secant cannot be faster. Okay. What about Nitin says secant is faster. So you can just tell, right? Regula Falsi is faster or secant is faster. And let me tell you, okay, fine. So I got 3 answers. Okay, secant is faster, Amar Pandit. Okay, yeah, secant is obviously faster because we are not comparing everywhere. We are not calculating, the root is lying between this and that, right? We used to do that in Regula Falsi. Here we are not doing that, right? That's why secant is faster always. Is it good? Yes, anything can fail, Amar Pandit, all right? Anything can fail. Okay, So that's called convergence. All right, that's what it is. Sometimes, you know, even Newton-Raphson also fails sometimes. That's the best thing. That's the best procedure or best technique out there, right, in terms of at least speed. But yeah, everything might fail, okay, depending upon the nature of equation and obviously the convergence criteria that we are going to put. We have not talked about any convergence criteria here, okay, so that's what it is. Okay, fine. So the next one is Newton-Raphson, and this kind of question is being asked, okay. Someone asked, I think Abhishek was asking, who was asking? Amar, what are you asking, Amar? Okay. All right, so sometimes what happens is, you know, this kind of question is being asked in a competitive examination. I picked this up from GATE, okay. I just picked it up from GATE, all right. So what it says is the first iteration is given by x0 minus f of x0 upon f dash of x0. And here if I want to write the function fx, then I can write something like that, x minus 10 cos x. Okay, this is just converted to a function like this, x minus 10 cos x. Okay, is it good? Okay, fine. So what do I write? F dash x equals to 1 plus 10 sine x. The problem with Newton-Raphson is that, you know, you need to have an initial guess, okay, and because of this sometimes Newton-Raphson also fails, okay, it doesn't converge many of the times, okay, but it's in our level what is given is an initial guess is given, all right. So that is nothing but x0 is pi upon 4. Okay, now what is f of x0? That is f of pi upon 4. That is nothing but pi upon 4 minus 10 cos pi upon 4. What is f dash of x0? That is nothing but f dash of pi upon 4. Okay, that is nothing. I just need to plug in this value in f dash x, right? Okay, so what is that? So that is nothing but 1 plus 10 sine pi upon 4. Yeah, Amar, in that case it might also, you know, generally yes, if it's too far it doesn't converge, generally speaking, all right. Again, it depends on the function as well. Yes, you're right, if it's too far from the root, it might have convergence difficulties, okay. So can you please tell me what are these values, and can you please plug in these values here in this? So what are you getting? x1 equals to pi upon 4 minus fx0. How much are you getting this and how much are you getting that? Okay, so if you're not there, if you don't have calculator, I have the solution with me. So f pi upon 4 is minus 6.288. So that's nothing but minus 6.288. Okay, and f dash pi upon 4 I have 8.071. So 8.071. Okay, so I'm going to just plug in there minus 6.288 upon 8.071. So can you please tell me what are you getting? How much are you getting? So x1 you're getting 15.13. Okay, no, you should not get 15.13, Shubham. Okay, I hope I have answered you, Omar. All right, I think I have answered you. Okay, so how much are you getting that? Come on. Yeah, That should be the answer, 1.56. Okay, Shubham, I think you got it wrong. 15.13 is too much here. How much are you getting? Yes, so because it's just up to 2 decimal places, so I'm going to use 1 point up to second decimal place, so it is going to be 1.56. all right, is it good? Yes. So these kind of questions actually are asked in GATE after, you know, first iteration, second iteration, maximum second iteration. All right, and again, you know, you can go back home and try to solve this using Newton-Raphson. All right, is that good? Hello. So I'm done for today, and yes, we have Vision 2021, and we can start free trial right now. The second batch has already started. I enjoyed the session, guys. I hope that you also enjoyed it. And let me ask you a question. Why do you use, okay, even before leaving, why do you use these things? Okay, why do you use numerical methods? Why do you use numerical methods? Can you please tell me? Because I had explained it to you at the beginning of the session. So so I'm going to go leave you, all right, with your own preparation. Just tell me, okay, why do you need numerical methods? Firstly, that should be clearer, right? Someone asking about, you know, applied application. So here I'm not going to give you any application of it. I'm going to just, you know, maybe if you take up the course there, I'm going to tell you exactly where numerical methods is applied. And this, dear, my dear friends, all right, this is the most important chapter in your life if you're going to go to a simulation industry. Okay, that's what it is. So the question is, why do you use numerical methods? Why? For programming, Amar Pandit says for programming. Okay, at least you're trying, Amar. It's good that you're trying, okay, to get concepts. Abhishek, not exactly, okay. And because I've already told you that, you know, okay, because right now I don't have time to show you a simulation. I would have told you, okay, how a simulation works, and that uses the concepts of numerical methods, guys, okay. Use for comparing the result. Okay, Shubham, so let me tell you that, okay, let me take an example, okay. E to the power 10x to the power e x square dx. Can you integrate this, yes or a no? Can you integrate this thing, this terrible looking thing? Yes or a no? Yes or a no? Can you integrate it? No, right? No way. No way you can integrate that, right? Yes. So anything that we cannot use, you know, the normal methods, okay, to solve, they can always be solved using numerical methods. Are you getting that? They can always be solved using numerical methods. And let me tell you that life is a differential equation. Everything in life can be described using a differential equation. Even the most basic equation, force equals to dp upon dt, is a differential equation, right? So we need to solve many differential equations, and generally, you know, we use numerical methods to solve very typical, you know, very difficult differential equations, right? Okay, so Nitin Dada, I just told that whatever cannot be done using normal methods are done using numerical methods. That's all. That's why we do numerical methods, all right? Because in real life examples, you get very typical functions, very typical scenarios, and yeah, if you are going to meet again, I'm going to show you, you know, an example of a simulation, as I've been telling you, right? So that's why we do numerical analysis or numerical methods. All right, for mechanical engineers, let me tell you that this area of numerical analysis will give you the maximum opportunity there, right? So again, yes, if you're going to join, we are going to talk about these things in more prominence, okay? And I'm done for now. I hope that I added value to your lives. And let's see what's okay. We also have some discounts over here, guys, okay? And I hope that I added some value to your life. And if you could not understand this, go back again, you know, repeat, revise. Everything becomes very easy if you revise, okay? So thank you very much, and keep on smiling and keep on, you know, dreaming, dream high, have an aim, a big aim, all right? A big target, and I think that you're going to be there, all right? But don't worry if you could not understand. No one understands it. If I'm from government college and will order today, Anshi, you're from government, right? Government college, and it's written here, right? A government college. So we also have discounts like that. Okay, I had shown you, right, the discounts over here. So you'll be getting this discount as well, I think, 27 to 29 Feb. So 30% extra, I think you are going to get, okay, Arshi. So you can just call the customer care, and maybe that you will get more discount today, because today is the last date, okay? Here you can call, and I suggest that just do it, okay? So thank you very much, and thank you guys. All right, just keep on smiling. I'll see you again. Thank you. Bye bye. Take care.